Assalamu alaikum, welcome back to the channel. This is going to be the second video of the playlist data structure in Python. In the previous video, we have seen the working mechanism of stack, its implementation in Python, and today we will see about queue. Uh, the queue in data structure is very similar to the queues in real world. Like if we see a queue in the bank or queue anywhere, the person who comes first will get the benefit first. While in stack, we have seen that the element or person which has come first will be retrieved at the last. It will go at the bottom. The person coming at the last will be retrieved first, or the element coming at the last will retrieve first. But in queue, it's not like that. It work on the mechanism of first in, first out. I mean, the element that has been inserted first will retrieve first. For example, if I insert three values like 1, 2, and 3, their storing order will be like the element which come first will store on the top, and then the element will which come after that will store after the value that has been already stored. For example, the 2 has been stored after the 1, and then 3 stored after these two values, and so on and so forth. If I just go on to store values, then the preceding value will come after these stored values. So while on the retrieving end, the element on the top, the element which has been inserted first, we retrieve first. Then if we remove this element, then we will be able to retrieve this element, and so on and so forth. We will just retrieve element, then if we pop this element or remove this element, then we will be able to access this element. And this stack and queues are special purpose entities. We cannot just jump onto direct. We cannot directly access the third or any element of our desired. We have to follow the sequence like this order: the first in, first out. The element which has been inserted first will be retrieved first. This mechanism has to be followed. We cannot just violate the rules. So as for stack as well, the its mechanism is like first and last out. So the value that has been inserted at the first will be retrieved at the first. We cannot break the rules and just we can retrieve it first. So coming up to the implementation part, we will implement on the same as the implementation of stack, like I did it by the linked list base, not the array base. So the advantage of using the linked list that we have a waste space available. We have a space until our RAM is not full. While in array case, we have to allocate the size first, then we have just limitations, then we can insert only values that that has been that the array has size. So in linked list, we have a waste size. We can insert as many values as we want. So it will just occupy the size as our values, as how many values we have inserted. So just coming up to the implementation part, first of all, we have to create the node class. This is basically is the linked list. So it will retrieve two parameters. First is the data part and then the next part. So creating our two data members, data and the self dot next part. I will keep it public because if I want to access it outside the class these data member, then I would be able to access these. So this was our linked list class. So now we will create our queue class. So in queue class, I will have two data members. First will be the head part, and I will keep this part as private. Now the purpose of creating two parts is that the head will be pointing to the first element and the tail is storing the value of the last element. So I don't have to just go through loop. For example, if I want to insert the value at the last, so I have to find the place where the head next part become equal to null. If you follow the video I made on stack, you will have a better idea what I mean by this. We will just insert a value on the head, then we have to move check whether its next part is null or not. If it is null, then we can store value in the then we can store a whole node in its next part. So if I want to insert a third value. So I have just told you that the retrieved value will be the head value. So the first element that is inserted in the head is the first element. Then if I insert a second element, then it will be stored in the next part of the head. So if I want to now insert the third value, then I have to first move the head to the second node. Then I have to move check whether the next part is empty, null or not. If it is none, then I can insert a node. So on and so forth. If I have 100 values, then I have to move the head 100 times next to its next part to insert a value. So instead of doing this, I will just create a maintain a tail pointer. It will do what? It will just keep on pointing to the very last element. So if I insert any next value, then I will just directly just assign it to the that I will directly store into the next part of the head. Don't have to move the pointer every time a value comes in. So there are two functions. First is to enqueue the element, so it will receive a data part. I will just create a temporary pointer object here, and this will be getting the node. So every value we just insert in will have the next part none. For example, if like the working mechanism of queue is like the value comes after will store at the last. What does that mean is that there will be no part next to it. So I have just assigned it the data part to this node class. This object is will have a class of node, this whole node, and in this data part it has the data value, and the next part will be none because this is going to be the last value whatever it is. So I have to just check it, the condition. If my list is none, for example there is no element in the list, then what will we do if we will just assign both our head and tail to the very first value we have in our array. So this statement will do. You can see that there is no element now in the queue. So this is the first element. So head as well as the tail is pointing to that element firstly inserted. So if I assume the second condition that the head part is not null, we have the very first node in our queue. So the second element, how will it going to be stored? We will just store the element in the next part of the tail. Now tail is pointing to what? There is only one element in the list. Head is pointing to the same element, and now the tail is pointing to the same element. So if I just uh, store the if I want to store the now next element, the tail next part will have the link to this object that has been newly inserted. This is the node that has been newly inserted. So the tail next part will have this node. So afterward, I will just move the tail to that node. Now what I have done here is that first I have just linked the tail next part to the next node, and then now I have to move the tail to the node that has been lastly inserted. So what happened now is tail and head was pointing to the first element. Now if I have seen that there is already one element in the list. Now I have just linked the tail part to temporary to the next node. So first element has linked to the second element, and then I move the tail to the second element. Now if the third value comes in, so this condition will be false because head is not none. So this object will have the node, newly inserted node. Then the tail after two values was pointing to the second value, so its next part is also none. So in the next part of the tail we have the third element. So there is now a link between second and third element as well. So I will just move the tail to the next element, which is third. So on and so forth for every value inserted, this operation will be same. So if I want to just assess the top element, I will just return head dot data part. So I have to check as well. Empty function, I will just return head. It will check for me. Oh, sorry, these members are private and we have to write them like with the self. So now I have created the sufficient functions to assess the value and check whether whether the list is not empty or not. This will be used in the retrieval of the. So another necessary function is dequeue the value. So like so I have told you that the element that if we want to dequeue the value, we start dequeuing it by the top element from the head. The head is pointing to the first element. First element was there at the first position. Now the second element comes after the first one. So they basically return the next one should be the second element. So we have to move the head, not the tail. Not we cannot remove the tail part. So we can remove just the sixth element, and there will be no turn for him. For example, there is a queue in the bank, and there comes three-person, a person number 1, 2, and 3. If the one person has done his work, then the next turn should be of the second number, not of the third. And same as the if we want to remove the element, we just remove the first one, not the third or second one. So first element is removed. Now the turn is of second element. In our case, the head is pointing to the very first element. So if we just move the head part to the next part, then self dot. So head will be just moved to the very next part of this. So this is it. This is so this is it. This is our queue implementation. So if we just the advantage of using these linked list in the Python is that we don't have to free the memory because there is no heap allocation. We have not used the new pointer like we used in C++. In the Java, we have the garbage collector. We just allocate memory on the heap, and it's just get automatically fed by the garbage collector. But in C++, we have to explicitly delete that memory we allocated on the heap. Like in the linked list, we just allocate every memory on the heap. So if I am to create the queue object now here, yeah, queue has been assigned the queue. So if I use this enqueue function, and if I insert data 10, the another advantage of using the this data structure in Python is that I don't have to specify the type explicitly here. I can use it generically, like for every data type. While in C++, you have to template it this whole class. We create a template of this whole class because we have to specify the data type as well along with the variable declaration. In Python, the data type is automatically directed, so we don't have to bother ourselves for, uh, to explicitly telling that this queue object will be of type integer or string or anything else. So if I am to assess the value, so while q dot empty function is not none, then just keep on printing the q dot top and then just pop the element. Oh, sorry, dequeue the element at the top. Dequeue, come on. So sorry. So this is it. If I just go on and run this, so we can see that the value that has been inserted first has been retrieved first, and the preceding value 20 has been retrieved. So if I just insert another value, in our case, the duplication is allowed. So if I just insert 20 after this and go and run this, then this will work fine. There are data structures available in Python which do not allow the duplication. For example, the binary tree that do not allow the duplication. So these arrays are very special purpose arrays. For example, like stack, queue, and then we have the binary tree. These are like special purpose entities. Then we have the concept of hashings. The linked list, uh, the linked list we have in our singly linked list, doubly linked list, circular linked list. These are not the special purpose entities. We can access the front element as well as the bank element stored in the singly linked list or doubly or circular. So in the preceding videos, we will see about singly linked list doubly, and then the so on and so forth for the trees, binary trees, real trees, and um, then the hashing concept. We will follow along everything. So for now, this is it. I hope you get the better understanding of what dequeue is. If you don't get it, you can comment in the video, and I will try my best to clear you out. So for now, Allah Hafiz.